for the workshop. Yeah, but I'll give a few more minutes. We're still less than 200, and then we'll start. Just to let you know, the session is being recorded from now. But yeah, that's the time for the drop-in session. If you have any questions related to the module or materials, please pop into my office and you can ask your questions. It can be anything about the module itself or the materials that we covered until now. So feel free to come along and ask questions. My office is WBS in WBS 2070207. So it's the ground floor, and might be a bit tricky to find my office, but once you know it, then you'll be fine. Great. If you're still on the 200, I'll give one more minute and then we'll start. Okay, let's start. So if you remember, I'll just repeat the process. We started by translating a written or verbal statement to a mathematical formulation, which was then solved using manually using graphical solution method, only if we have two decision variables. And then in the next step that we practiced last week, we solved the problem using computer software like Python. Again, we did it manually by introducing everything ourselves. And I showed you that when we do it like this, basically writing the decision variables, constraints, and objective functions yourself, basically plugging in the numbers, the coefficients in the objective function or the coefficients in the constraints, it just increases the chance of having errors or mistakes. And I told you that this week on week 4, we start to build a model, and then by just essentially importing the data set, we will have the model and we solve it. This is mainly because if there is any change in the model, I mean in terms of numbers or coefficients, right-hand sides, coefficients of decision variables in objective function or constraint, we don't want to intervene and change anything in the code. We just want to run the model again, that we will practice it today and in the workshop this week to see that we will have the least intervention and interaction with the code. Just once write the code, and then for different data sets, which they all have the same format, we'll be able to solve the problem again and again. Okay. So if you remember, this is our model that we have, and just let me have a quick look here. I'll just check the lecture slide quickly. We made a few changes. I'm not sure if this one is the one that has the changes. Sorry for that. Give me a second, please. Quickly, I'll check it. Okay, yeah, that is the one. Okay, fantastic. Sorry. Yes, this is the model that we covered last week at the end of the workshop. And this is the model that was shared with you on week 2's workshop, that we couldn't cover it, but we covered it last week, and we wrote the code for it as well, right? And this is the basically this is the transportation problem. So in transportation problem, basically what we have is we have a set of like factories ABC, and we have a set of distribution centers, and we want to send a product diapers from the factories to the distribution center, and from each of the factories to each of the distribution centers, because distribution centers, they have all the demand that we have to satisfy. On the other hand, each of the factories, they have a capacity that we cannot exceed, right? That becomes a problem, right? We want to, and there is a cost obviously associated with transportation, and it differs from each factory to each distribution center based on the distance, the time it takes to reach them, or whatsoever, which is something that we have in reality. It is an optimization problem because we have to wisely decide from which factory we have to satisfy how much of demand of each distribution center. You may decide to satisfy the demand of a distribution center with a single factory, or you may use, you won't decide, the optimization decides. For optimization, the best solution is to satisfy the demand with two factories or three factories even. Because distribution or transportation cost is different, we have to decide on this wisely. We model the problem here as a linear programming model where we have the objective function, which is the total transportation cost of these factories to the distribution centers. We said that we have 9 decision variables because we have 3 factories and we have 3 distribution centers. So in total, we can send from factory A to distribution center X, distribution center Y, distribution center Z. You can send from B to X, B to Y, B to Z, from C to X, C to Y, C to Z. So in total, we have 9 distinct decision variables. For each of them, as we said, there is a coefficient for the decision variable in the objective function, which are like the individual transportation cost of each truckload, which is sent from each of the factories to each of the decision and distribution centers. On the other hand, we had a few constraints. The problem tells us basically what are the constraints. It says that there is a capacity with respect to what any factory can send, and there is a demand that we have to satisfy. So the first set of constraints that we have here is a supply constraint that we have. For each of the factories, we have to make sure whatever we are sending from this factory to each of the decision in all distribution centers should not be more than the capacity of the factory. For factory A, for factory B, and factory C, I call it a set of constraints because they have something in common, right? For each of these constraints, we have a right-hand side, which is the capacity of the factory, and on the left-hand side, you have whatever we can send from this factory to all distribution centers. This is the first constraint. The second constraint, you have the capacity of the factory, factory B, and on the left-hand side, you have the total that can be sent from this factory to all distribution centers. And finally, we have the third. We have another set of constraints, which is the constraint on demand. The demand of each of distribution centers should be satisfied. And again, we call it the set of constraints because they have something in common, right? On the right-hand side, we have the demand of the first distribution center, which is 3, and on the left-hand side, we have whatever that this distribution center can receive from different factories. For the second constraint of this set, we have a similar constraint for the second distribution center. We know the demand, which is 4, and on the left-hand side, we have the summation of whatever is sent to this distribution center. And finally, we have the third one where the demand of the last distribution center that we have on the right hand side. On the left hand side, we have whatever that this distribution center is receiving from A, from B, and from C. And finally, we have non-negativity constraint that we know we have 9 decision variables. This is 9 because we have 3 distribution center and we have 3 factories. That's why we have 9. So basically, if I know some of the stuff here, if I know the capacities, if I know demand, if I know how many factories I have, how many distribution centers I have, and the individual cost, I should be able to build this model. And if anything changes, if you have 3 factories initially we had, if it is now 5, I want to be able to immediately build a new model with new numbers that we have. And this is the whole thing that we want to do. This is a concrete model, and for a concrete model, again, we know that we basically know all the inputs first, and then we build the model. This is unlike an abstract model in which we don't need to know the inputs beforehand. It's a parametric model. So we're going now to build a parametric model, but again, at the end of the day, it becomes a concrete model because I have the data set. I just want to first remember that concrete model, you first have the data set and then you build the model. In abstract model, you don't need to have the data set. Okay. Now we're going to build the parametric model. When we're solving the model in Python, we first input the data set and then we solve this parametric model. Okay. I see a message on chat box. This is a general question, but when are we finding out our groups for um ask program team? To be fair, I have nothing to do with that. It just ask my confirmation that if I'm okay with the groups, I am. So if you ask them, they will guide you. Now, the next slide, I'm going to just build this model that will have the objective function, the constraints, and the decision variables. Not only for this case, as I said, if you have like 5 factors or 10 factors or 10 distribution centers, again, you have the same model. So the objective function here is the summation of all individual costs multiplied by their associated decision variable, right? So I want to minimize the total cost. I wrote it in this way. So here you can see I have decision variable, decision variable, decision variable, decision variable, 9 of them. It is 9 because I have 3 factories and I have 3 distribution centers, and each of these decision variables are multiplied by an individual transportation cost. What I have on the right hand side, basically, I have TLIJ instead of AZ, BX, CZ, CR, CY, or all different indices that I have, but just put IJ. I represents factory and J represents distribution center. So I have TLIJ, which is my decision variable, the set of decision variables that I have. I is either A, B, or C. J is either X, Y, or Z. In our setting, this two example that we have, it is multiplied by a transportation cost, which is CIJ. Again, the same indices that we have. I and J. I represents the factory. J represents the distribution center. I can be A, B, C. J can be X, Y, and Z. I have another message on the chat box. I have nothing to do with the groups. Okay, program team deals with the groups. So if you have any questions about the groups, please do contact them, because as I said, it's not on me, it's not with me. I just answered this question. So you can see someone else said they have the same question. So I have nothing to do with the groups. It's on the program team. If you have any questions about that, just ask them. Just prepare we all do the lectures. We prepare the group assignment and we give them to the program team. They just handle it. So if you have any questions about that, just contact them. Now, decision variables multiplied by the individual cost that we have. Both of them, they have the same indices, I and J. I stands for factories and J stands for distribution center. But as you can see, as I said, I and J, they just represent some factories and some distribution centers. I can be A, B, or C. Now I have to indicate by the summation what are these I's and J's. Here I indicated that I goes from 1 to M. M is the last, basically last element that this I can get. We basically, if you remember from Python training workshop that we had, if you have 4 I in something, that I, if you remember, it's something just shows that it's an iterator to show that what is going to be in each of the iterations that you have in the for loop. That's exactly the same. If you remember, we had name. I changed it to I said it can be K, it can be J, it can be iterator or whatever that you want to call it. So that's exactly the same. IIJ or use here, you can use H and K, you can use factory and basically distributions and or whatever that you want to use. You have to indicate where this I is going to iterate in. I put this I from 1 to n and j 1 to m. So basically, I'm going to how many times it's going to iterate. Basically, it goes from 1. If you remember from range, it goes from 0 to something. That's Python. It starts from 0, but here we have like mathematics, and it goes from 1 to a number which is n. How many times it's going to iterate? If I have a, b, and c as the factories, it starts from I1, which means that the factor is A, I2 factor is B, basically, and I is equal to 3, factor is C. Our n here is 3. The same goes for j. It goes from 1 to m. M is the number that the biggest number that it can get, which is like 3 again, because we have 3 distribution centers. When j is equal to 1, we have x as our distribution center. When j is equal to 2, we have y. And when j is equal to 3, the last number equal to m, it goes to z. We want to minimize this summation. Okay? That's the total transportation cost that we have for this specific problem. So easily you can see if n is based on the data set that we have. If data set that we have, it goes for factors A, B, C, and distribution center X, Y, Z. If you had A, B, C, and D, then immediately the code should understand that you have 4 factors. So don't want to go and change anything. This n can be 4, can be 3, can be 5, can be 10, or whatsoever. Now, we have constraints. I said that we have 2 sets of constraints, one set of constraints for supply and one set of constraints for demand. We're going to write them individually here. So no matter how many supply constraints you have on the left-hand side, when you write it like this parametrically or generically, when you increase the number of factors, a new constraint will be generated with your model. Because we know I have 3 constraints, supply constraints here, because I have 3 factors, right? If I have 4 factors, I'll have 4 constraints. If I have 10 factors, I'll have 10 constraints. Okay? So the right-hand side is basically something which is an input of the problem. We know the right-hand sides are the capacity that each of these factors can supply, can send. It's 2, 4, and 4. It's given into the within the problem, within the data set that we have. If you had like 5 factors, then we would have 5 numbers for the capacity of these factors. On the left-hand side, however, we know that for each of the constraints, we are summing the whole thing that the factory can send. The factory can send to the first, second, third, or how many distribution center that we have. The summation, and for all of them, you can see all of them are less than or equality. The summation should be less than or equal to the right-hand side, which is the capacity of the factory. So we write it in this way. First, right-hand side, it's SI. Remember that we said that we introduce I and J here. I as the factory, and J represents the distribution center. I'm writing the supply constraint, and the supply constraint is written for each of the factories. So I have to use the capacity of these factories, and the index that I have used is the index which is used in the objective function as well for the factory, which was I. So SI is basically the capacity of the factories that we have. On the left-hand side, you can see all decision variables have a coefficient of 1, and the summation here is over what? Can you write it on the chat box? The summation on the left-hand side, we have 3 constraints, and these 3 constraints basically are written for each of the factors. There is a summation on the left-hand side, right? On the left-hand side of the first constraint, we're writing the first constraint for the first factory. What is the summation on? Can you write it on the chat box? If they are unable to assign the group in a reasonable time frame, given this is just 2 weeks before deadline, and they have not mentioned anything at all, fortunately. Would you consider? And don't worry about the group assignment. Just focus on the contents of today. Of course, we will think about that. Don't worry about that. Can you answer the question now? Forget about the group assignment. If there is anything which should be considered, of course we will do that. We won't do anything to harm your work and studies, of course, because someone couldn't assign or something. No, they're working on it. They asked me on Friday to confirm, and I confirmed. And soon they will just come back to you with the groups. You will have your group assignment, and you will have enough time to do your group assignment. Okay, don't worry about the group assignment. So my question was, what is the summation on? Uh, the summation of the left-hand side. You're summing these decision variables. So if you're not familiar, or if you forgot about summations, please have a look at the math refresher that you have, because I presume that you know that. So summation should be over something, right? The summation here is over the distribution centers. This was my question. On the right-hand side, we have a right-hand side which is related to the factories. On the left-hand side, you have the summation of decision variables, which is over the distribution centers. Now, this one that I have here, this single, this constraint that I have on the right, written here on the slide. Can you tell me how many constraints it shows me? How many constraints we have when it is written in this way? Is it 3? Is it really 3? We want to write 3, but what I have here, is it 3? Someone said. It's not infinity, but I is the correct answer. Do you remember from Python virtual, when you have a for loop and you have the iterator, which is I, K, or whatsoever that you have? If you check the variable explorer, it always shows you the last number or the last element which was assigned to the iterator. It can be 1, 2, 3, whatsoever it is, right? When you have I here, I is a single index, right? It's a single index that we have here, which is I, and I can see from the chat box. It's a single index. I have to indicate how many different variables this I can get. That's why I have to add this part. If you don't add this part, I will be a single number, which is a single index, and it will get whatever that is assigned to it. So you have the summation on the left-hand side, which is over the distribution centers. So this J here, we have two indices, I and J. J is basically what we are summing on, and this I is basically what we have on the right-hand side. And this I can get 1, 2, 3, 4, 5, 6 until n, whatever it is. In our setting, it is 3. When I is equal to 1, we know that we're talking about factory A. If I is equal to 2, we are talking about factory B. When I is equal to 3, it is about factory C. So, and remember that we use the same index that we use here. If you're talking about the factories, it should be I, because I introduced this I and J in a way that I always represent the factories and J represents the distribution centers. Okay, so this says that now we have 3 different constraints. Basically, we have n constraints. In our setting, this n is equal to 3. Therefore, we have 3 constraints. We do the same for the demand constraint. For the demand constraint, again, we have something in common for this set of constraints, right? On the right-hand side, you always have demand. On the left-hand side, we know that there is a summation of decision variables. All coefficients are equal to 1, and all of them are greater than equality. Again, we do the same. On the right-hand side, we will have the demand of each of the distribution centers, which is dj. So this should be j, because I use I here to represent the factories. J is used to represent the distribution centers. So everything that we have on the left-hand side should be greater than or equal to dj, which is the demand of the distribution centers. On the left-hand side, you have the summation of these decision variables, and the summation is over what? Factories or distribution centers? Can you write it in the chat box? The summation on the left-hand side, it's over the factories, right? Factories. So when on the right-hand side, I have something about distribution center. The summation here cannot be about distribution center. It should be about the other index that we have, which is I. And I represents the factory. So the summation of all decision variables over the factory should be greater than or equal to dj. What I have written on this slide, how many constraint it is? Can you tell me how many constraint it is? It's one constraint. It's one constraint for the j that we have. You're right. That j can be x, can be y, can be z. So it's a single constraint. I have to add this part to make sure that I'm writing m constraints. M is equal to 3 in our setting, and it represents the distribution center. Now take a moment and think about how we have to write the non-negativity constraint. Just take a moment and just do it for yourself. If you want, you can write it on the chat box. based on the explanation that we have here. How we have to write the non-negativity constraints? TLIJ greater than or equal to 0, but TLIJ greater than or equal to 0. How many decision variables it shows? If you just write it as TLIJ greater than or equal to 0, it's a single constraint, right? It's a single decision variable because I and j, again, with the same logic that we went for this one, if you write it as TLIJ greater than or equal to 0, like this, it's only one single constraint for one single decision variable. You have to make sure that you add these parts as well, where I is from 1 to n and j is from 1 to m. You can write it as 1, 2, 3 and 1, 2, 3 for I and j, both of them, to make sure that you're writing the exact constraints that you have for all decision variables. So basically what I'm trying to say here is that when you have an index for a decision variable or for a parameter, for a coefficient or whatsoever that you have, you can't just leave it alone. You have to indicate what values this this index can take. Okay, when you have an index in your decision variable, in your constant, in your objective function, you have to make sure that you indicate what values this index can take. Okay, now we have different sets here. We have a set of suppliers and we have demands. Basically, I'm calling them the sets, suppliers and demands. Supplier is the set of supply points. In our case, there are like A, B, and C factories, and I have another set which is the set of demand points, and these are X and Y and Z in my setting. Basically, this N here, I goes and iterates in the set of suppliers, and J goes and iterates in the set of demand points that we have. So N here is equal to basically the number of suppliers that I have, and M is this basically the number of elements, the number of distribution centers that I have in the demand points. I, as I said, goes and iterates in this set of A, B, and C, 1, 2, 3, and J also goes and iterates in the set of the distribution centers, which are X, Y, and Z. We have parameters here. Cij is unit cost of delivery from supply point I to demand point J. I is in the suppliers, which are A, B, and C, and J is demand points, which are X, Y, and Z. Si is supply of the suppliers or capacity of the suppliers, and I is in the set of suppliers. So I'm just showing you how you can formally represent the problem. Si is the supply or capacity of the suppliers, and I basically is in the set of suppliers which are A, B, and C. Dj is demand of the demand points, where J is in the set of demands X, Y, and Z. Okay, any questions up to now? Any questions? Yeah. Now, with your computer, if you want to please launch Spider or whatever, Python, whatever ID that you use. If you remember from basically from our Python workshop, we did this, importing Excel file into Python and work around with it. We're going to do this today because we want to build the model that I showed you, this model here that we have. This is our model, right? This is the model that we built. It is a parametric model, but in our case, we are going to build a concrete model. For a concrete model, remember that we have the data set. So I know this n is equal to 3, this n is equal to 3. I know this Cij. I have 9 values for this one, 1, 5, 7, etc. And I know I have 9 decision variables because I have like 3 factors and 3 distribution centers. I know this n is equal to 3 because the same n that I have here, this n is also equal to 3. This is the same m that I have here. So I'm going to build a concrete model. I build this parametric model. Remember that in the abstract model, you don't need to indicate how many decision variables you have. what is n, what is m. It's just n and m. But in concrete model, it will indicate what are n and m, and then I will have n in my model, which goes and take the value that I created in my model. Okay. Now there is a data set that I shared with you on modules webpage. If you go and download it, I presume you already downloaded it. Just let me check if it's there. It's not this one. Yeah. So you have to be able to download the Excel file. Please download the Excel file, and then we will start by importing this data set, which is called week 4 transportation problem dash input.xls x. And then we just imported this as a data frame that we did in the Python workshop. Try this now when your laptop is, if you launch Python. If you got any error that you don't have XLRD package, then you can pip install it with pip, and then you will have the package. Remember, if you need any package, basically you can just try to install it using pip install XLRD. If it works, that's fantastic. If it didn't, in the workshop I will try to have a look, but in the meantime, until workshop, you can Google and see how you can install it in your computer. Another thing which is very important here, if you get this error, no such file or directory error that you got, this means that the folder is not correctly given. Remember that you have to go to this path, basically this part of Python. For me, it's on the top right, and click on this one, or if you click on this one, you will see different path that you have. If you click on this one, you go to the folder, the folder that you saved this Excel file, and then you should be able to import it without this error. Okay, let me go to this one. Let me just reset the kernel, and I will fire my file here, and then we start to write it. Okay, first, let's start by importing pandas. So if we go back to the notes here, we're going to use pandas because here we can see to import an Excel file. We need to basically use pandas. There are other ways that we can use, but I'll use pandas, and pandas is something that we use a lot. Import pandas as PD. Remember that we can assign a nickname because we don't want to write again and again pandas when we are we have to indicate if we are using an object from a package. So PD is easier. Then we create a file name. This is what we did also in the Python workshop. And remember that I told you the best way is to go to the folder that you have, copy and paste the name, and it is always safer because otherwise you may have like typos or something. I'm doing that. Just went to the folder that I have now pasted. And remember that oops, you don't see Python. Let me see. Do you see Python? Okay, you're seeing Python. So remember that what you write here should be whatever you see in the folder, and you have to indicate the extension as well. Okay. Once you have the when you have the name file name, you can import using pandas, which is pd dot read Excel, and now we have to give the file name and the worksheet's name, which is input. For my case, I'll open it up and I'll show you. Index column is equal to 0. Now let me just go fire the Excel file. I'll show you the Excel file. It is not this one. Okay. This is the Excel file that we have. Okay. Put it here. And okay, this is the Excel file that you can see, right? So you see the Excel file here, we have a name for the worksheet. So you may have different worksheets in the same Excel file that you have, and you only want to work on a specific worksheet. So that's why here we indicate which worksheet we are going to work on. And with index underscore column equal to 0, basically we make sure that the index number of rows are excluded, that we don't need them. This is the file that we have, right? We know the name of the factories, and we know the name of the distribution centers. We know that the last column of this data set that we have is the supply or the capacity of these factories, and here the last row is essentially the demand of these distribution centers. And what we have at the middle here is the transportation cost. So I'm just explaining you this because we said that we want to be independent from the data set. If we change the data set, we want to be able to get a new model and solve it. What we do here is when you're working in industry, you can give the persons that you're getting the data set from a template like this. You can tell them, if you have an extra factory, please add a new column here, not there, behind it, and then create a new factory, which is D, and then create the give me the transportation cost, and also give me their capacity. So in this way, if you go and run your code, you will see today and this week, again, you will have a model now for 4 factories. This is the whole point of the thing that we are trying to do today and this week. So as I said, we know where it's which part of this data set represent what part of the model that I have. So the number of rows that I have here is basically n, which is the number of factories that we have. I goes and iterate in the set of A, B, C. The number of columns from here to here, you know that the last column should be excluded because it gives us the capacity of the suppliers. This gives me the number of columns from here to here, from B to D. It gives me the number of distribution centers that we have. And J, which represents the index for distribution center, it goes and it iterates in X, Y, and Z. I know these 3 numbers are the capacities of the suppliers, which are the right-hand side of the first set of constraints that are created. I know this last row here, these 3 numbers are the demand of distribution centers that are used as the right-hand side of the second set of constraints. So I know them, and I just want to have a communication with the code to extract this information with the Excel file that I have. Okay, now let's run these parts. If I run this, F9, 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 I'm all right. I didn't get any error here. Let me change this. And if I run this again, just to show you, no such file or directory for the Excel file that I created, because here, if you check this part of Python, the path is not correctly given. I saved this file in another folder, and if I change the path and rerun it, now I get the dataset input imported, and you can see it in the variable explorer. If you just double click on this, you can see that I have A, B, C demand, X, Y, Z supply. I have the supply or capacity of each of the factories, the demand of each of the distribution centers, and individual transportation costs from each of the factories to each of the distribution centers. Index column equal to 0, basically excluded another column here as 0, 1, 2, 3, which are an index given to each of the rows. I don't need them because I already have an index assigned to them as A, B, C, and demand. I'll close this one. Now, I have the data set imported to Python. Now I have to make sure that I have everything that I need from this model. I'll stay here. So this is the model that I have. I need to know what is N. I need to know what is M, or the set basically. I need to know the set of suppliers. I need to know the set of demands. I need to know CIJ, transportation cost. I need to know SI, I need to know DJ, and once I have them, I'm able to build the model, right? This is what we are trying to do. In the meantime, let me check the chat box. If you don't define the name of the sheet while reading the Excel file, will it pick the first sheet automatically? I don't really recall if it does it that way. Just try when you're home after the lecture. Try a single, you don't need to have a real data set. Just try and see if it works. It might be the case. So the question is, if you don't indicate, as I did here, that you're going to get input, which is the worksheet in Excel, if you don't indicate it, is it going to get the first worksheet of the Excel file? I'm not really sure. Have it a go and see if it works that way. In case we don't have the index in the Excel tab, should we change, depending on the data set? So if you have an example, you mean if we don't have this ABC here, do we need to make index call as 1 or something? Depending on the data set that you have, if you need to have an index. If you don't set it as 0, then it will, let me do that. We did it in the workshop as well. So if I get rid of this part, let me just get this, and then here, without index column of 0, if I run this, and then just run this, do you see that I'll have 0, 1, 2, 3, which are not useful for me. So I don't see any point of having it. But depending on the situation, you may need to not use index column of 0. Okay, let me go back to my data set. And now I was telling that we need NM, we need CIJ, we need SI, DJ, and once I have them, I will be able to build the mathematical programming model. Now, I'm going to get different parts of this data frame. This is the data frame that I have. If I have A, B, and C, then this gives me the list of the set of the suppliers. X, Y, Z. This gives me the set of change anything. This gives me the set of distribution centers, X, Y, and Z. Okay, so and remember that we're talking about this part, right? Where we have the numbers. Can you tell me which columns in Python give me A, B, and C? Can I write it in the chat box? Which column, rows. So I'm looking for the index of the rows that give me A, B, and C. Are they 0, 1, and 2? That's perfect. 0, 1, and 2. Okay. But 0 to basically 2. That's what we want to get, right? But if I give 2, this means that basically we are going from 0 to the last one, but I want to exclude the last one because I know the last one is always demand. This is what I ask. 0, 1, and 2. Or 0 to the last, excluding the last one. 0 to 3, excluding 3, because I know always based on the template that I built, I know the last row represents demand, and I don't want that one. It's written actually demand. I don't want that one. So basically 0, 1, and 2. But do you remember that rather than writing a number for the last one, what would we use in Excel? -1, right? -1. That's better. Because if I use -1, I don't need to know how many rows I have. I want to go from 0 to -1, excluding -1. If you use 2 or 3, then when you change the size of the data set, you have to go and check your code and change that to 5 because you have 5 factories. And we don't want to do that. That's why we use -1. So I'm going to get the suppliers. Suppliers is equal to supplier's name. Okay, it is df. From the df, I will use location, like if you remember, and I have to indicate which indexes of this data frame I want. Index as we said, from 0 to -1. So do you remember when you're giving the start point is included, the stop point is excluded. That's why from 0 to -1, this means that you start from 0, you go until the last one, you exclude the last one. And then I'll have to indicate which column it is. Which column it is, the data, that's column, the first column, which is column 0, right? So this is df dot columns 0, okay? I'll have to now indicate that I want to, when you use a data frame, remember that it's like dictionaries, and it gives me keys and values. I only need the keys here because I want the name of these suppliers. If I just run this, this gives me A, B, and C. If we don't write these keys, let's see how does it work, just to show you. If I run this, this gives me, do you see that it gives A, B, C, and it gives the first column as the values for these keys. So that's why we add keys, to make sure that we just get the names of these keys, the name of the suppliers. And if you check this one, you can see the size is equal to 3. This is what I wanted. I wanted to introduce this n, which is equal to 3, this m, which is equal to 3 as well. And I want to be independent from the data set. If there is a new row here as factory d, I want to directly have 4 as the number of factories in my data set. Now I'll do the same. Demand names is equal to df location, and then df dot index of what I want to get x, y, and z. Can you tell me which index it is in Python? Which index it is? It's index of 0. It's just one row that I have, right? And I'm giving only the index. Index is for rows, right? It's 0. Now, in terms of columns, which columns I have to give? Oops, here. Which columns are these? From 0 to the last one, excluding the last one, because last one, I know it is always capacity. So this is, again, 0 to -1, and dot keys to only get the name of the, where is Luke? Okay. The name of the demand points, which are X, Y, and Z. Again, if you check in the data variable explorer, the demand names has a size of 3. So if I have a new column for a new distribution center, essentially, when you give the input with the same code, it will give you M, which is now equal to 4 rather than being equal to 3. Initially, it was, right? So now I have this data frame, which is essentially the data that we have from the Excel file. I got the supplier name and demand names. Supplier demands name, basically distribution centers or X, Y, and Z. And we have supplier names, which are A, B, and C. Now, I'm going to convert this data frame from DF to a NumPy array because it's easier to manipulate data in NumPy. For me, at least, it is easier. And remember, we covered NumPy as well. NumPy as NP. Now, I'm going to create a new variable, which is data frame converted to NumPy. And now df is the name of the data frame that we have. 2 underscore NumPy will convert the data frame to a NumPy array. I'll show you what is the difference. This is the NumPy one that we have. You can see that all labels are gone. X, Y, Z, demand, supply, A, B, C, all of them are gone. This is the NumPy version of this data frame. I can keep both of them open. So this is the NumPy version, and this is the data frame version. In the data frame, we have labels for the rows, for the columns, unlike NumPy, which gives us solely the numbers within the data frame that we have. Well, I'm doing this because easily I can get different parts. I know this last part is the supply of A, B, and C. I know these three are the demand of each of the distribution centers. And I know these ones are the individual transportation costs of different factories to different distribution center. Now I'm going to do that. I know which part is what, and it is simply NumPy. So I'm going to get different parts of this NumPy array. Cost matrix from this df NumPy. If I ask you, can you tell me in terms of rows? Remember with NumPy is just give two indices for rows and then for the columns. If it is two-dimensional, and just indicate which parts you want. If this is the cost matrix, transportation cost, can you tell me which rows and which columns I have to get? I have to get from this NumPy array to form a cost matrix or transportation cost matrix. Can you tell me which rows and which columns I have to get? Columns, rows 0, 1, and 2 as it is written, and columns 0, 1, and 2. Again, we don't want to deal with the last number. That's why we use -1. So in the code, we just need to indicate it is 0 to -1 for the rows and 0 to -1 for the columns as well. 0 start point, it is included. -1 is the stop point, it is excluded. If I run this and just print or run this, it gives me 151,271,582. I know the orders, right? I know, and we know array is also ordered. I know the first row indicates the transportation cost from factory A to different distribution centers. The second row indicates transportation cost from factory B to all distribution centers. And finally, we have row 2 or 3, basically the third row, which is index of 2 in Python. That's transportation cost from factory C to distribution center X, Y, and Z. Now I know all of them. Now, having said that, I'm going to stop here. We'll continue working on this code on Wednesday and Friday with some extra problems that we will work on as a part of the workshop. I will stay and answer your questions. The recording will continue, so if you need to dash out, feel free to leave the room. You will have access to the question and answers which are being recorded now. If you're leaving, I will see you on Wednesday or Friday, but feel free to stay and ask questions. We go up and see if there is any questions in the. I answered this one. Does the Excel file need to be set up exactly as shown? What do you mean need to be set up as shown? I created a template and I'm reading data, I'm building the model based on this data set. So if you want to use the same code, then the data should be like this. If you make changes in the data set, for instance, let's say, rather than having supplies here, if you just put them somewhere else, then you have to accordingly modify your code first time to get the different parts correctly. But then whenever you just change the data set again, your model will be generic and you won't need to change anything in the code. Could we have gone from the to number conversion? Why did we do that? You mean from why we converted data frame to NumPy? Manipulation, data manipulation is easier. So I just need to get these parts of this data frame. This is the data frame that I have. When you have data frames, You have essentially you have labels for the rows, you have labels for the columns. And I don't need the labels because I already got the labels to build a set of suppliers and set of demand points. Now I just need to work with the numbers. And if you want to work with numbers, NumPy is better than data frame, to be fair, at least for me. That's why I converted to NumPy to manipulate these numbers easier. Could we have skipped all the demand names, supplier names? Why? Could you skip all demand names and supplier names? Why you wanted to skip them? What is the point of not having them? Having them, it helps you when at the end of the day you wanted to print the values, how much you're going to send from each of the factories to each of the distribution centers. You could just use the names, right? If you don't have them, if you want to print them for someone to see from A to X, you're sending this much. It wouldn't be easy. It would be 0, 1, 2 rather than ABC. Now we have ABC. It might be the real names: Coventry, Birmingham, Manchester for the factories. For the distribution centers, it could be London, Milton Keynes, and Sunderland, for instance. So when you wanted to print the values for each of the decision variables, you wanted to show how much you are sending from Manchester to London to Milton Keynes to Sunderland, for instance. So I would say that you would need it, not for the sake of building the model, but for other purposes you will need it, and we will see. Hope we answered your question. Fantastic. No worries. If you have any other questions, just write it on the chat. Do you use pandas to extract names, NumPy to set numbers, matrix, and then aggregate them? Yes, and we use pandas to import data as well. You can't use NumPy to import Excel file to Python. We use pandas initially. The thing is, we use pandas to import data. That's the only way that we have. When you import any data using, when you use pandas to import data Excel, it becomes a data frame. We extracted the names from the data frame, and then I don't need the data frame anymore. So just converted it to NumPy because I'm going to work with the numbers. Meant that I didn't see this one. Meant that can you change the position of the table instead of A1 starting at D2? Yes, of course you can. So what you're saying is if you just take this, try them. That's the best way. So I'm going to try to see. You have the Excel file and you have the code. So just try them and see how it works. Just do it now and see how does it work. And if I just open the data frame, you can see the ones on the top are being shown as not available, so they are empty. So they start from the first one. Now the thing is, that's totally fine. When you're reading your data, you have to make sure that this row here is not row 0 anymore. It's row 0, 1, 2, 3, 4, 5, 6, 7, 8. So you can change the position, but as you can see here, you will get a different setting in the code. Therefore, you have to make sure that which rows are the rows that you're focusing on, which columns are the ones that you're focusing on. Answer this one, okay. Okay. So I guess I answered your question now on this. I know we are using Python for this module. Are there any pros and cons of using Python R? Python is, I mean, for optimization, Python is used more, so the documentations are extensive. With R, I'm not aware of any documentations for optimization with R. And I guess Python is more often used in industry as well. That's the thing. I'm not familiar with R, to be fair. I mean, I'm familiar, but I'm not fluent in R as I am in Python. So Python is widely used, uh, and for machine learning and data science as well. I guess it's used more than R. For optimization, definitely Python is used more than R. Can you please repeat time and days to see you in the there is an announcement on the modules webpage for the drop-in session. Please refer to that one, because if I tell you now again, you will forget. Just have a look at the announcement. It's Friday from 2:15 to 3. And my office number is 0207. Thank you. Someone copied and pasted the announcement. You won't have access to the chat after the session, but you have access to the modules webpage. So. Could we still go to your office before the drop-in session if you have questions? What do you mean? I won't be in the office. Or if there are times that I'm in the office, but so I have a lunchtime after the first workshop, and then I'll have another meeting. My free time is the time that I put there. So if you want to see me, I don't intend to have one-to-one meetings. I mean, there are things that you want to discuss with me one-to-one. That's something that, yeah, of course, you can book a time with me, but book it beforehand so that you know I'm in the office and I'm available to see you. You may come to the office and I'm in a meeting, so I can accept you. But for modules related inquiries, I prefer to have a time that is available to everyone, not for a single person. Do you have any other questions? I'm going to stop recording because I don't think you have any more questions. I'll see you on Wednesday and Friday.